So now let's look at the next problem, number 7. And again, just to make things easier, I've labeled some of the lines. The two horizontal lines are A and B, and the lines that are on diagonals would be going down like this from left to right would be line C, and then up from left to right would be line D. And then we've got 4 angles that are labeled 1, 2, 3, and 4. And again, I'm going to do this in any order I want, as long as I end up finding the measures of all the angles. Now we're told that line C and D are perpendicular lines, right? Because they are creating a right angle, and two lines that intersect in a right angle are perpendicular. That's a definition. Well, there are many ways to show this, but we've already mentioned that when two perpendicular lines intersect, every angle at the point where they intersect is a right angle. So both 3 and 4 are right angles as well. But so we can write in immediately, because the definition of a right angle is 90 degrees, we can write in that measure of angle 3 and the measure of angle 4, both 90 degrees. But let's see how we could prove that. So let's say we only knew that one of the angles was a right angle. How could we prove, for example, that angle 4 is a right angle? Well, we did this a few moments ago. It's clear that this right angle and angle 4 are a linear pair. They add up to 180, and if this is 90, then this has to be 90, right? And similarly, for that reason, angle 3 is a right angle. But also notice that angle 3 is a vertical angle. It's vertical to a right angle. So using the vertical angles theorem, we can also conclude that angle 3 is a right angle as well. Again, that's another example of the linear pair postulate and the vertical angle theorem of two different theorems and postulates that both lead you to the correct conclusion. Well, so now we know angle 3 and angle 4 are right angles, but we are still trying to figure out what is angle 1 and what is angle 2. Now, in a little while, in a couple of weeks, we're going to learn a theorem that could help us a lot in terms of figuring out the measure of angle 2 and measure of angle 1. Because these are triangles. And as we may have started to notice, the sum of the angles of a triangle is 180 degrees. So that already tells us what this angle has to be. But we can't use that theorem yet because we haven't really gotten to triangles and we haven't really proved that theorem. So is there another way that we can determine the measures of angles 1 and 2? And there is. Okay, because if you notice, lines A and B are parallel. We're given that. And angles 2 and this 40-degree angle down here share the same transversal. They both share D. D is part of each of those angles. And when D cuts the parallel lines A and B, it creates angles 2 and angle 40 degrees. So what kind of angles are these? Well, they're between the parallel lines, they're interior angles, and they're on opposite sides of the transversal. So they're alternate interior angles. Okay, so we can say that alternate interior angles are congruent, so therefore measure of angle 2 has to be 40 degrees. So we know this is 40 degrees, and by a very similar argument, the measure of angle 1 is 50 degrees, because when cut by the transversal C, parallel lines A and B create angles 50 degrees and angle 1, and these are also alternate interior angles. They're between the parallel lines A and B, but they're on opposite sides of the transversal C. 50 degrees is to the right of C, but angle 1 is to the left of C. So these are alternate interior angles, which are then congruent, and so the measure of angle 1 equals 50 degrees.